So Randy Jackson walks us through one of the most important tools, input-output analysis. And I really like the way that he kind of goes through this. So this is one I kind of want to focus on. Um, and I think the way he describes it really helps set this as a way to see how industries are connected with each other and how shocks ripple through an economy. So the fundamental accounting relationship in the IO framework is that the output used as inputs to industry, so intermediate outputs, plus output for consumption, the final demand, is equal to all the output that is produced total, so the gross output for a given time period. Now, this isn't something that's magical, it's simple accounting. So you can break it down any way you like with any number of industries and go from like three industries all the way to like 3,000 separate industries. And that's going to depend on what your needs are. Something that he focuses on is when you look at the regions or you look at the industries, you can do sort of like a all others. And if you're trying to focus on, the effect of a change in a specific industry. Now, the most common use of the system of input-output equations is the assessment of impacts of changes in final demand or final demand shocks. So these shocks can be any number of changes. It can be very different. So he gives some examples. So there's like military base closures that was really important at the end of the Cold War to estimate what the effect would be for these areas of a military base closing when that's one of the major like drivers of, I guess you would call it industry in the area, one of the biggest employers. It could be simply new businesses opening in an area. It could be new regulations making an industry more expensive and seeing what the rippling effect of that would be on the whole economy in the region. So when the activity in one industry increases, the demands placed on its suppliers also increases because that firm or the firms in that industry now need to get more inputs into their product. Now, these suppliers are going to need additional suppliers to satisfy their new demand. Output produced by an industry to be delivered to final demand, these are direct impacts. Now, the inputs needed to increase, but inputs for the initial increase are referred to as the impacts of the first round of spending. It can go on through several different rounds, and that's why we have to do this analysis and why we can see such large multipliers from a single policy change or effect in one specific industry. So the core insight here of input-output analysis that we've talked about and read about already is that every industry produces goods and services and uses inputs from other industries to do so. So a change in the demand for one is going to go through and ripple through a bunch of other industries and other firms. None of these industries operate in isolation. So the foundation, like the real important part that I like how he goes into it in the regional section of this is the transactions table. So kind of like a big spreadsheet. So you have each row with like representing what an industry sells to the other, and then columns representing what it buys. So if we have three industries, agriculture, manufacturing, and services, the cell in the agriculture row and the manufacturing column shows how much the manufacturing sector buys from agriculture as an input. So at the bottom, we see payments to primary factors like labor and capital. And then down the right-hand side, we see final demands, these purchases by consumers, government, and then exports out of the region. But the whole system as a whole balances because these are accounting principles. So your total inputs are going to equal your total outputs. So I like to say that it's elegant or as elegant as accounting can be. The next step is to express those relationships in a set of proportional terms. So instead of just knowing dollar amounts, we can see how much the input from one industry is needed to produce another dollar of output. So these proportions are called technical coefficients, and he talks about this a little bit, and they make up the A matrix. So if manufacturing buys 20 cents of inputs from agriculture for every dollar of manufacturing output, then the technical coefficient of agriculture to manufacturing is 0.2. So now the full A matrix is going to show the relationships for every pair of industries. Once we have that A matrix, we can express the economy in a simple equation. You have the total output, the intermediate, which is going to equal the intermediate demand plus the final demand. So if we rearrange that around, we can get the classic linear model. I don't want to dig too much into that. I don't want your focus to be thinking about Leon Teeth here. I basically want this to be practical and applied. So you're thinking of how we use this versus all like matrix algebra going into it. Um, but it's through this matrix and through the Leonti inverse that you can estimate the multipliers. So you can get that number to tell you how much total change results from an initial shock. So an output multiplier tells us how much the total output in the region increases when the final demand in one industry rises by $1. So an income multiplier shows how much household income increasing from that same stage. An employment multiplier doing the same for how many jobs created directly and indirectly. Now, we can do a national version of this model and we can do a regional version of this model. The regional version adds some complications. So Jackson does a pretty good job explaining this, how regional models deal with this, and how they deal with the shortcoming of data. It's really difficult to get this data down, at local levels all across the country. So they use location quotients and some other estimation methods to approximate what share of inputs are supplied locally versus imported. They also do, he goes through the example of Chicago and then looks at the rest of the state of Illinois and the rest of the US. That's something very common to have, especially like the rest of the US or the rest of the region. Um, and of course, he's very, very transparent about the limitations of this model. It's a really great tool to be able to use, but it's not the sort of like perfect estimation that's going to tell you exactly what's going on, give you the perfectly accurate number. But still, it is really useful and used quite a bit in regional analysis, especially for the applied policy type work.